Okay, so in this video, I'm going to show you how to calculate the latent cooling capacity of a DX cooling coil in a makeup air unit going from 95, 78 down to 50 degrees dry bulb and 49.5 wet bulb. So to do this, we're going to use this equation here, which is not used very often, which states that the Q latent capacity, which is BTUs per hour, equals, in this case, we're going to do it for 1,000 CFM units times 0.68, which is a convenience factor that we will go through in another episode. Please note, this is at sea level. Okay, it will be different if you're at higher elevations, times dW, which is the delta of the grains per pound of dry air. So that's the key here, grains per pound of dry air. So all we have to do using our chart is to determine the grains here. So how do we do this? Well, in this chart, the grains are listed over here on the y-axis. So what we'll do is we'll take our straight edge and we'll go from 95, 78 and draw it over to the side here. And just to make sure it's precise, I looked it up earlier and it's 117.4 is the exact value. 117.4. Let me make sure I got that right. That is correct. Minus the grains at the lower conditions. So 50 degrees is something like over here. Let me make sure I get this accurate. Something like this. I think that technically it's like 51.6. 51.6. Okay, so we'll say that's 51.6. That's the accurate value when you use a app to calculate it. So 51.6. So now we have the delta W in grains per pound of dry air, which is 65.8. So we'll multiply this times 0.68 times 1,000 CFM, and that equals 44,744 BTUs per hour. And again, that's Q latent. So that would be the latent capacity. So the latent capacity of this coil, using the psychrometric chart, turns out to be about 45,000 BTUs per hour.